In this video, we're going to design a circuit that enhances the stock EROD LS3 one-fan control scheme. By adding a few components to the fuse relay box, we can A. Power two fans, B. Let the air conditioning system make the fans run, and C. Put a delay between the spin-up of fan 1 and the spin-up of fan 2 to lessen the demand on the electrical system. Let's get started. The first thing we're going to do is show the relay that came installed in the fuse relay box for fan 1, and we're going to call it ECM Fan Control Relay because it is controlled by the engine control module. It's going to be powered by an ignition switched power source that has 12 volts when the car's key is turned on. ECM Fan Control Relay will be controlled by pulling down pin 85 by a blue wire or a green wire that comes from the ECM. Big thanks to two viewers of our fuse relay box modification video who correctly pointed out that if you pull these wires down with some other source, like an air conditioning circuit, it's going to piss off the ECM and cause a check engine light. Instead of driving a fan directly, the new purpose of ECM Fan Control Relay is to generate an active low signal that tells a new relay we'll call Fan 1 Relay when to turn on. Fan 1 relay will also be powered by ignition switched power on its positive coil pin, pin 86. The output of this relay is going to be a 10 gauge wire that runs to the front of the car and powers one of the two electric fans. So we need to supply lots of power to pin 30 on fan 1 relay because when fan 1 relay activates, it will create an electrical connection between pin 30 and pin 87. To turn fan 1 relay on, we will create a 12 volt difference between fan 1 relay pins 86 and 85 by driving pin 87 of ECM Fan Control Relay low. In order to drive pin 87 of ECM Fan Control Relay low, we have to have ground connected to pin 30, which means a change to the factory wiring. In the factory wiring, an orange power wire is connected to pin 30 of ECM Fan Control Relay. We're moving that orange wire from ECM Fan Control Relay to the new Fan 1 relay. Then we're connecting a new small gauge ground wire to pin 30 of ECM Fan Control Relay. Now let's add a new feature that allows the air conditioning system to turn on the fans. A trinary switch monitors the pressure in the high pressure side of the air conditioning system and pulls the trinary switch run fans signal down whenever the pressure has built up to a certain point. Running the fans lowers the pressure in the air conditioning system. Next, let's add support for a second fan. This relay, just like the other two, will be powered by ignition switched power, and it will drive a significant amount of current out as our fan 2 power wire. To do that, we have to supply pin 30 of fan 2 relay with plenty of power. So we will run a second identical orange wire from a new not shown maxi fuse in the fuse relay panel to pin 30 of fan 2 relay. When fan 2 relay activates, pin 30 and pin 87 are connected electrically and power is supplied to the power out fan 2 wire. Now, if we just hook up the same enabling wire from pin 85 of fan 1 relay to pin 85 of fan 2 relay, they would both turn on simultaneously and it would work. But spinning up an electric fan draws a lot of current, so wouldn't it be better if we could spin up fan 1 completely before spinning up fan 2? To do that, let's delay turning on fan 2 by about 5 seconds. Then we'll only have about half as much current draw at any given time, so we won't have as much voltage droop in the car's electrical system. To delay fan 2 relay turning on, we need to delay pin 85 getting pulled down to ground. So we need something we can control, like a transistor. The one used here was one we already had, and that's the reason we used this specific part, an IRF 510. We're going to have to delay the turning on of this transistor, so let's add a capacitor that will take some time to fill up with charge to the gate pin of the transistor. But then we need to slow down the current that's flowing into it, and that's why we added a resistor. It took some trial and error to find that about 150 k ohms sets the delay to be about 5 seconds. Less resistance gives a shorter delay, and more resistance gives a longer delay. The last thing we want to add is a fan 2 relay protection diode. There's a thing called flyback voltage that happens when you cut off the current that's going through a coil. There's still a magnetic field around the coil, stored energy, and that energy has to have somewhere to go. If you have a diode in the circuit like this, The flyback voltage on pin 85 being higher than pin 86 will cause current to flow through the diode, so no harm, no foul. Without the diode, the current has nowhere to go, so the voltage on pin 85 can spike and may cause damage to the transistor. There are a couple of things that I want to mention that are notes on the schematic. One, for the turn on and turn off times for our fan delay to be equal, the voltage that activates the transistor would have to be 6 volts, but it's not. This transistor turns on at 3 volts. So to turn on, the voltage has to go from 0 to 3 volts before anything happens. But to turn off, it has to drop from 12 to 3 volts before anything happens. So the turn off delay is quite a bit longer than the turn on delay. We don't see this as a problem. It's just something that could surprise you if you're not expecting it. And the final thing I'd like to note is that if fan 1 relay fails, fan 2 is also not going to work, because the output of fan 1 relay is what turns on fan 2 relay. Ideally, you'd like to have fan 2 continue to work fine without fan 1 relay working, but that's not what we built and tested. Everything shown in this video is something we did build and test. We've tested it a fair amount and it works great. And most importantly, no check engine light. If you found this video helpful, won't you please smash that like button? Thanks.